All right, hi everyone. This is chapter 1, lesson 10 for Ravenclaw. This is the last lesson of the chapter. So today we're going to be talking about comparing real numbers. So when I compare real numbers, a blank blank, a rational number, I guess I should move this down. Sorry about that. A rational number is a number that can be expressed as a ratio, A over B, where A and B are integers and B can't be 0. B can't be 0 because if B is 0, bad things happen, right? Because we can't divide by 0, all right? So the next one I have is an irrational number. Is a number that cannot be expressed as the ratio A over B, where A and B are integers and B cannot be 0, all right? So pi is a great example of an irrational number, okay? So numbers that are not blank are called blank numbers. So numbers that are not rational are called irrational. The square root of any number that is not a perfect square number is irrational. So the square root of 2 is irrational because it's 1.41 and it goes on forever, okay? The set of rational numbers and the set of irrational numbers together make up the set of real numbers, okay? So remember way back to lesson 1. Let me flip back to it real fast for you to look at. Oh no, table of contents. Okay. Okay, remember this? Yep, it's coming back. So you may want to flip back and forth between this page and the next page when we're going through this. So this is page 8, just so you remember. Okay, and we are way back over here on page 32. Okay, so you can go back and forth, look at 8 if that helps you. All right, so it says name all sets of numbers to which each real number belongs. So the first one I have is 0.2525. The decimal ends in a repeating pattern, so it is a rational number because it is equivalent to 25 over 99. Okay, remember back in lesson 1 we talked about those. Square root of 36 equals 6, so it's a natural number, a whole number, an integer, and a rational number. Okay, so natural, whole, integer, and rational. All right. 3 is negative square root of 7, so square root of 7 is negative 2.645, blah, 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 blah. Decimal does not terminate or repeat, so it is an irrational number. All right, so a couple of try problems for you to try. So I have A, B, and C. Pause the video. Go ahead, try to solve the problems. So you're looking at the sets of numbers to which each real number belongs. Come back and we will go over the answers together. All right, so now that you've tried them on your own, let's look at them together. First I have A equals the square root of 10. Well, the square root of 10 is not a perfect square. There are no two numbers that are the same that will multiply to get me 10. So this is irrational. All right, letter B says negative 2 and 2/5. Negative B, negative 2 and 2/5 isn't a whole number. It's not a natural number. It's not an integer, because integers, remember, are whole numbers, either positive or negative, but it is a rational number because it can be written as a fraction. Okay, so then I have C. C is the square root of 100. Okay, so 10 times 10 gives me 100, which means it is a perfect square. So 10 is a natural number, a whole number, an integer, and a rational number. Okay? So on page 33, you have this cool little ice cream cone, right? So it gives you all of this, okay? And then it gives you some numbers to look at. So I want you to pause the video, try solving the ice cream cone, get as many numbers as you can in, and then go ahead and we will go over the answers together. All right, so now that you've unpaused the video, let's go over the answers together. So the first one I'm going to look at is irrational numbers here at the top, okay? So in the box down here, right? In the box down here, I'm going to look at for my irrational numbers. The only irrational number that I have is pi. Okay? Next, I'm going to look at my natural numbers. Remember, natural numbers are whole numbers, positive whole numbers that do not include 0. Okay? So my natural numbers are 1, 2, 3, 10, and that's it. Okay? Then I'm going to move down to my whole numbers. Well, my whole numbers include all my natural numbers plus 0. So I have 0, 1, 2, 3, 10. Then I have my integers. My integers include negative and positive whole numbers. So any negative numbers I have negative 1, negative 2, negative 3, 0, 1, 2, 3, and 10. Okay? So remember, you include the next line up. All right? Then the last one I have here is rational numbers. Rational numbers include all my natural, all my whole, all my integers, and anything that I can write as a fraction. So this includes negative 1, negative 2, negative 3, 0, 1, 2, 3, 10. It also includes 1.5, 3/4, 0.009, 5/6, 1.76, 3/2, p/q, 3.14, and negative 2/17. So basically almost all of them except for pi. Okay? So that includes all the rest of those. All right, so the cone holds the real number system, cherry included. Cherry is the irrational numbers. Okay? So here's my fun flavors. It's kind of a cool, fun thing that you can look back on. All right? So let's go to page 34. All right, this is the last section of comparing real numbers. So compare and order real numbers. You can compare and order blank blank real numbers by writing them in the same notation. So write the numbers in decimal notation before comparing or ordering them. Decimal's probably the easiest thing to compare them to. All right? So let's look at some examples. I have 4, 5, and 6 over here. We're going to look at 4 first. So it says fill in each bubble with less than, greater than, or equal to make a true statement. So I have the square root of 7, and I'm comparing it to 2 and 2/3. So I'm going to change the square root of 7 into a decimal. So square root of 7 is approximately 2.645751311. 2 and 2/3 I can also change to a decimal. I get 2.6 repeating. Okay, 2.6 repeating is going to be larger than the square root of 7. So square root of 7 is less than 2 and 2/3. All right, looking at number 5, I have 15.7%, which I can change to a decimal as 0.157, And the square root of 0.02, which I get 0.141 approximately, okay? 15.7% is bigger. Okay, number 6 asks me to order the set. Square root of 30, 6, 5 and 4/5, 5 and 3.6 repeating from least to greatest. Verify your answers by graphing them on a number line. Okay, so write each number as a decimal. So that's my first step. Square root of 30, approximately 5.48. 6 is 6. Okay, 5 and 4/5 is 5.80, and 5.36 repeating, approximately 5.37. We can round up. Okay, so that means everything has 2 decimals, which is great. Makes my life easier to compare things to. So I can graph them on a number line. 5.37 is the smallest out of this group, so that means 5.36 repeating would go first. So that one's gone. Okay. Then I have 5.48, which is the square root of 30. 5.80, which is 5 and 4/5, and then I have 6. So 1, 2, 3, 4. Okay. So I have a couple of try problems over here. I have D, E, F, and G. Go ahead, pause the video, try them out, and when you come back, we will go over the answers together. All right, so the first try problem I have is D, the square root of 11, and I'm comparing it to 3.13 and 1/3. All right, so if I come over here to my workspace, so square root of 11, I get approximately 3.3166, and I'll stop there. 3 and 1/3. Do. Is approximately 3.33, and so on and so forth. 3.333 repeating is bigger than 3.316, right? Because this I can technically go 3.12 and 3.33. This is bigger. So 3 and 1/3 is bigger. So I come back over here. It's letter D. Square root of 11 is less than 3 and 1/3. All right. Letter E says the square root of 17 and 4.03. Square root of 17 is approximately 4.123, and 4.03 is already a decimal. When I look at these, this is bigger than this, so that means the square root of 17 is bigger than 4.03. So when I come over here, square root of 17 is greater than 4.03. Okay, I have F, square root of 6.25 and 250%. Okay, square root of 6.25 is 2.5. 250% is also 2.5. They're the same, so they are equal to one another. So F is equal. All right, so the last problem I have is comparing. So I want to order the set -7 negative square root of 60, negative 7 and 7/10, and negative 66/9. So negative 7, 7.00, go to 2 decimal places. Square root of negative 60 is negative 7.75. Okay. Negative 7 and 7/10 is negative 7.70. And negative 66/9 is negative 7.33. Okay, so the first thing that I want to do is I can actually graph these on a number line. So the first one I have is 7. Right? Negative 7 is here. That's negative 7. Negative 60, we said was negative 7.75. So that's right about here. Okay. Then I have negative 7 and 7/10, which is right here. And I had negative 66/9, which is negative 7.3 repeating. So that one's a little bit off that. So negative 66/9. Okay, so looking at this, I can tell my order is going to be from, remember they asked us least to greatest. So I have negative 60, negative 7 and 7/10, negative 66/9, and then negative 7. And that is the end of lesson 10.